Okay, welcome back all my beautiful calculus students. We're going to be working on question 19. We were asked to evaluate the lower sum approximation of the area bounded by f of x equals negative x squared minus 2x plus 15 and the x-axis using 4 subintervals. I want a lower sum approximation. And this question has a couple little twists to it as we'll see as we go throughout the problem. First off, the function I'm dealing with is a quadratic, and the quadratic is opening down. I can tell that from the leading coefficient being negative. I'm also not given any AB interval that I have to find the area bounded by, so the fact that this is a quadratic that's open upside down, I'm hoping it's above the x-axis, and when it comes back down, it's going to cross the x-axis at a couple of points. That will end up being my interval from A to B. So I'm going to find my x-intercepts. And in order to find my x-intercepts, I'm going to let my y value equal 0. I'm going to factor out a negative sign just to make this a little easier for me to work. I like to factor my quadratic when I have a positive x squared. So I have xx plus 5 minus 3. I believe if you check that, you'll see that that works. And that tells me that my x-intercepts are going to be a negative 5, 0 and a positive 3, 0. So I'm going to sketch this graph just a little bit and see what's going on. Also, I'd like to know about my vertex. And the vertex is negative b over 2a and then f of negative b over 2a. So if I take a peek at my original function and I do negative b over 2a, that'll give me a negative of a negative 2 over 2 times my a here is negative 1. And then, what does this give me here? I don't know what my f of that is yet. We'll work on that. But a negative of negative 2 gives me 2 over negative 2 gives me a negative 1, comma, something. I need to know what is f of negative 1 now. And so this is what I'm looking for. I don't really care about this thing right here. It just drops down. So if I take a negative 1, put that back into my original function, what is going to be the y-coordinate of my vertex? I think I'll do that right here with you. F of negative 1 is the opposite of negative 1 squared, and then minus 2 times negative 1, and then plus 15. So f of negative 1, when you take a negative 1 and you square it, you get a positive 1, but this negates, so we have a negative 1 again. Negative 2 times negative 1 is a positive 2, and then plus 15. This gives me a 16. So the 16 turns out to be the y-coordinate of my vertex. I have a vertex that is negative 1, 16. I want to give a quick sketch of this graph so that I can understand a little better what I'm trying to find. So I'm going to come over here and I'm going to give a quick sketch. And I know I need to go at least up to 16, hopefully no higher. If that's my vertex, everything should open down from there. So no higher. So negative 1 and then 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Negative 1, 16. And then my x-intercepts were 3, 0, 3, 0, and negative 5, 0. Negative 5, 0. So this is a pretty steep function here. And I want to find the area bounded by this, and I don't really care what's going on below because I want the area bounded by the function itself and the x-axis. So I think I'll throw a 0 into my original function. If I throw a 0 into this function, I get a 15 out of the deal, which is my y-intercept, 0, 15. And since I'm here, I might as well do a 1 and a 2 as quickly as I can. F of 1 should equal, and I'll go back to the original again, 1 squared minus 2 times 1 plus 15. If I take a 1 and I square it, I get 1, and there's a negative sign on it. So negative 1 minus 2 plus 15. So what does that give me? Negative 3 plus 15 is a 12. F of 1 is equal to 12, so 1, 2, 3 below. 1, 12. And then let's just take a 2 and do the same thing here. I'm looking at, I think I'll erase this and just put a 2 in its spot. You guys can rewind your video if you want the rest of that other stuff. It's going to make this a 4. It's going to make that a negative 4. This is going to give me f of 2. Negative 4 minus 4 is negative 8 plus 15 gives me a positive 7 to the good. Therefore, 2 comma 7. So there's 2 and 1, 2, 3, 4, 5, 6, 7. I'm going to just put it right around here. So you can see how plotting a few more points helps you get the symmetry of the graph, or at least get you one side of it. And knowing that the graph is symmetric is going to help you get the other side of it. And there is the quadratic f of x. Then I'm looking for the area bounded inside this quadratic and the x-axis. So my interval does go from negative 5, and I'll put a bracket around that, all the way to 3, and there's my AB interval. All right, so I want this to be a lower sum approximation, and I want to use 4 subintervals. So if I'm going from a negative 5 to a 3, then that's a distance of 8. Divided by 4, that means each subinterval has to be 2 units long. So again, that subinterval is known as my delta x. The formula is b minus a over n. This gives me 3 minus a negative 5, which is that 8 I spoke of, divided by the number of subintervals I have, which is 4. It gives me the width of each subinterval has to be a 2. So I'm going from negative 5 to negative 3, to negative 1, to 1, and then to 3. And those will be my subintervals, each unit being 2 units long, each subinterval being 2 units long. Okay, now I want to notice that this is a symmetric graph, and it's symmetric over or about the line of x equals negative 1. So I'm going to do a little tricky thing here, and I'm going to find half the area, and when I'm done finding half the area, I'm going to double it. Now the reason I want to find half the area is because this is an increasing function up to from negative 5 to negative 1, and then a decreasing function from negative 1 to positive 3. And I have one rule that I follow if the function is increasing. I have another rule I follow if the function is decreasing. So instead of doing both rules, I'm just going to do one and double my area for this function itself that looks symmetrical. It is symmetrical over the line of x equals negative 1. It's not an even function. I don't know if hopefully I didn't say that out loud. It's not an even function because this function is not symmetrical over the y-axis, but it does have a line of symmetry of x equals negative 1. All right, well, let's get to work here a little bit. I am going to build my little rectangles because I need 4 subintervals. This cuts me in half. Here's another one. And I could play around over here and give you the other one over there, but I'm just going to look from negative 1 to positive 3. I'm going to go from negative 1 to positive 1, and then I'm going to go from positive 1 to positive 3. That gives me these 2 subintervals right here. And the other 2 are over here, but I'm just going to find this area, and then I'll double it, because what is here on the right side of the axis of symmetry also belongs on the left side of the axis of symmetry. So I want to find a lower sum approximation. I need to do base times height and base times height twice. One for the first rectangle, one for the second rectangle. And I don't know if it helps you or not, but I suppose if you didn't have your y-axis here, it might be a little easier for you to visualize those 4 rectangles. So if I want a lower sum approximation and my function is decreasing as I move to the right, you get lower and lower and lower, then I want to use the right bound value to create a rectangle that is actually beneath my graph. This rectangle has a base of 2, we knew it was going to, and it has a height of whatever the height is right here at 1, which I already figured out to be a 12. So the height of the function is a 12 right there. This gives me this area right there. Now the second interval goes from 1 to 3. And this interval, if I use the left side, I'm going to get that height of 12. But if I use the right side, my height is actually nothing. My rectangle is flattened completely down and out. So when I do base times height, my base will be a 2, but my height will be a 0. So 2 times 12 is 24. 2 times 0 is 0. That gives me a 24. That means that what I have shaded right here so far has an area of 24. And now I simply need to double 24, and that gives me an answer of 48 squared units. for this problem. And in a nutshell, and basically for a lower sum, all I'm getting is this picture right here. That's it. That's all I'm actually finding. And that is the end to this problem.